So welcome to the topic of gravitation. In this topic, we'll be looking in much more detail at the force of gravity. So the four forces that hold our universe together are gravity, the electromagnetic force, the weak force, and the strong force. Very recently, or reasonably recently, the discovery of a particle called the Higgs boson has hinted at or suggested that there may be a fifth force in existence. At the moment, we know very little about this fifth force, including whether or not it's actually real. So we'll stick with the four that we're familiar with. Of these four, gravity is by far and away the weakest force. So each of the electromagnetic, the weak and the strong forces are at a minimum 10 to the 32 times stronger than gravity. So the first and obvious question is, well, if gravity is so much weaker than those three, why is it that we only deal with gravity when we're looking at things on a large scale? So why is it that we don't talk about the electromagnetic force when we're talking about planetary orbits? And the answer to that will come in two parts. So the first is the distance over which those forces act. So two of those forces are very short-range forces. They act on a subatomic scale. And those are the weak force, or the weak interaction, as it's sometimes called, which is responsible for radioactive decay. It's responsible for a type of radioactive decay called beta decay. And beta decay occurs when one of the protons inside an atom is converted or flipped, essentially, into a neutron, reducing the number of protons in the atom and therefore changing the type of material that it is. So the weak force is acting on a subatomic level. The strong force is the force which holds the nuclei of an atom together. So in the nucleus of an atom, there are a very large number of protons squished very closely together. And protons are all positively charged. So one would expect that when you put two protons next to each other, they would repel, meaning that it would not be possible for atoms to exist at all. And the strong force is the force that holds those protons together. So the strong force is the force that means that we actually have matter at all. The last two forces are the forces that act over a much longer range. In fact, they actually act over an infinite distance. And these are the electromagnetic force, which causes like to attract and unlike to repel. And because of this trait, the electromagnetic force can be shielded against, which means although it has the potential to act over an infinite distance, it generally doesn't. So the electromagnetic force, as you can see, is made up of two different terms. It's the electrostatic force and the magnetic force. And the electrostatic force refers to the repulsion of like charges and the attraction of unlike charges. Whereas the magnetic force is the force that means that if we have two, for example, North Pole magnets or two South Pole magnets, they'll repel. Whereas if we have two opposing magnets, they will attract. And so you can see that the behavior of these two forces is very similar. And as it turns out, they're actually the same force. They're just viewed from a different reference frame. So that's why this force is termed the electromagnetic force. And I said that the electromagnetic force can be shielded against. And what I mean is, because unlike charges attract, it is not really possible for there to be very large concentrations of either positive or negative charged material. Because if we had, say, a planet-sized object of positively charged material, it would attract enough negatively charged material from the surrounding to become neutral. And once it was neutral, it no longer exerts any force on any nearby particles. Whereas gravity is always an attractive force. Because of that, it can't be shielded against. So gravity, if we have the same idea, so we have, say, a concentration of mass, and that mass has a small amount of gravity. That small amount of gravity will attract a little bit more mass. And once there's a little bit more mass, it has a little bit more gravity, and so on. So, unlike electromagnetism, gravity doesn't attract anything to neutralize it. So gravity is actually the only force that we see acting over an infinite distance. Gravity acts on all particles with mass, with energy, or with momentum. So for these two reasons, Gravity is the only force that we see acting over an infinite distance. So gravity is the force that is responsible for things like planets, planetary orbits, and galaxies, and right at the extreme end of the scale, things like black holes, which have a gravitational field so large that not even light can escape. So for the rest of this topic, we'll be looking in detail at how gravity influences objects on a universal scale.